investigate, this is called your remainder theorem. It has to do with what's a factor and what's not a factor. So we're developing your remainder theorem through this. And this is a nice theorem to use, because you can absolutely check either graphically or algebraically where your roots are and what your remainders are. So now, we bring down the first one, we multiply left to the right. 3 times 1 is 3. We add down. 3 times 3 is 9. We add down. 3 times 2 is 6. We add down. And if it is a root, a factor that is a root that crosses through our x-axis, it is a true factor. We have a remainder of 0. And we can see the 0 is also your y value, right? Good so far? Okay. Let's try the second one. F of -1. What is f of -1? 0. So now, when I divide this, and I divide this whole thing, what should this come out to be? 0. Okay, so let's see in fact if that happens. This is my factor, so when I set this equal to 0, my root is -1. Again, pull all your coefficients out. Start by bringing this first one down. Was there anybody not here on Thursday? No? Keisha? This is what we did synthetically dividing. We took out all the coefficients, but you have to account for every place. So in other words, this didn't have an x squared. And you can say it real simple. A 3, a 2, a 1, and this guy is a 0. So we got to pull out all their coefficients. Then we find the factor, we set it equal to 0 for a basic one. And then we divide. We say, bring the first one down. Multiply to the right. Add down. Multiply to the right. Add down. Multiply to the right and add down. And Gabe told us we should have a 0 there because, in fact, this guy is a root. Good so far? Okay. Find f of 1. Does f of 1 cross the x-axis when x is 1? No? Can you find it on your graph? It's probably easier to find on your graph than on mine. Can you find what the point is? So -12. So let's divide. X cubed minus 7x minus 6 over, and we're going to divide x minus 1. Now, we put our factors set equal to 0, so now we're dividing by a 1. Okay, so let's see what happens.
Why would you use it? Oh, never mind.
These two are different. These two are different. See this one and this one? This one used when f was -1. Our root was negative. Our x value was -1. Our factor is x plus 1, but set it equal to 0. So multiply, bring it to the right. 1 times 1, 1. Add it down. 1 times 1, 1. Add it down. 1 times -6, -6. Add it down. Now we didn't come out with a 0 that time. But what do you notice? Where did -12 come from? The point. -12 is the y value at here, when this is here.
Is that last number always going to be the y?
That's going to be your y value. That's your remainder theorem. That when you do this, if in fact it is a root, it is a factor that we can factor out, the remainder will be 0. If it's not, it will be the y value for that given x. So if I just put this equation in my calculator and my y equals, and I want to know if I divide by a 1, if I use x as 1, what will my remainder be? I look to see where my y where it intersects with the y, where it my coordinate point falls out for the y value. And there's my remainder. It's a nice way to check your division, because sometimes your division, you come out with these weird, and you're going to do a sheet where some of the remainders are pretty large. You can put it in your calculator, and you can certainly check in the table of your calculator. So let's try a little bit more. Find f of -3. Look at your graph. What is f of -3 as best you can tell? Looks like it's -12. So let's see, in fact, if that's true. So again, we take out all your coefficients, and we divide by -3, our x value. And what should this come out to be over here, if Carlos is right? -12. So let's see. Bring this down. Multiply to the right. Add down. Multiply to the right. Add down. Multiply, whoops, to the right. Add down. Does it come out to -12? For a minute I thought I had a root there. I'm like, uh-oh. -12. Okay? So you can kind of see what's happening here. Your remainder theorem is a nice little theorem that, in fact, if this is a root, it will be, your remainder will be 0. If it's not a root, not a perfect, like a perfect factor for this, the remainder will be whatever that y value is for that given x. Okay? It's a nice theorem, and I like the way that they proved it. So the last two parts just ask you to prove the -1 and the x of 0. So take a look at that very last one. It says this. We divided the x minus 1 over here. We did that already. We didn't do this one. So when I set this synthetic division up, what am I going to divide by? 0. Good, because I set this equal to 0. It's my factor. I set my factor equal to 0. And let's see what happens when I divide by 0. Kind of weird to divide by 0, but 0 is an x value on your graph. What is the y value for that 0? -6. So this guy right here should come out to say -6. So bring it down, multiply. Isn't anything times 0, 0? So no matter what we keep bringing down, it's multiplying, and it'll work out. So we can divide by a 0. Good? Okay, I thought I would spend a little bit more time with synthetic division. How comfortable are you guys getting with the synthetic division? A little bit? A little bit more comfortable? Okay, now notice in all of these divides, these were all by a linear, by a line, by x to the 1. They were all only by 1x, not an x squared, not a quadratic, not a cube or anything else. It always has to be the remainder theorem, x to the 1. It makes a linear in the denominator. Then that works. It doesn't work for any of the other ones. So let's have you, so pull out your coefficients. Make sure they're all there. Start with your highest, 2, 1, 0. What am I going to put in to divide by? A 1. Good. X minus 1 is my factor. Set it equal to 0. Bring down the 3. Multiply, move to the right. Add down. Multiply to the right. Add down. So now, is this a 0? Is this a given root for the equation? No, because it's not 0. So if you look at your table, when x is 1, is y -3? Good. So that confirms your remainder theorem. So it confirms that it's right. Now, you don't have to adjust your windows. Sometimes when you do these, they're really, really far off. You don't have to adjust your window because your goal is just to look at the table. So let's pull these coefficients out. What are my coefficients?
-4, -2, 6.
Good. Okay, what am I going to divide by?
-2.
Good. So let's bring down the 1. This is my starting place. -2 times 1, -2. Add down. Multiply to the right. -2 times -6, +12. Add down. Multiply -2 times 10, -20. Add down. -14. So is this a root? Is this a 0 of my equation? Nope. And if you looked at your table, the y value for -2 would be -14. So do we see these? The factor theorem is kind of nice. I'm just going to have you do one more. How about number 4? Let's do number 4 together. And then we'll change this up and I'll give you some other ones. Okay? What are my leading coefficients? 5.
0,
Good.
0.
Huh?
-20.
Yeah. Then a 0.
-84.
Good. So let's check these. 4, 3, 2, 1, 0. Start them and check them because if you leave those out, your answers are all wrong. You got to go back to the drawing board. What do I divide by?
-25.
Okay. So let's multiply. Bring down the 5. What is 5 times -5?
-25.
Good. To the right. Add down. So, in your calculators, what is -5 times 125? I'm sorry, times -25. Kind of negative way, huh? Nope, multiply. 125. Add down. What do you get? 105. Multiply -5 times 105. Add down. Multiply -5 times 5, -525. What is it, 2,000? Okay, and let's add in the -80 to that. -84. Well, subtract 80, negative,
541.
so 2,541. So let's see, in fact, if, when we graph this, if this is a point. You don't have to adjust your window to look at your graph. All you have to do is look at your table. Yep, we found it. Good. Good. So are we getting a little bit more comfortable with this? Okay. All right. I want to do a few more of the divisions because I know some of the divisions are fractions not working. All right. So what are my leading coefficients? Okay. What am I going to divide by? Okay, so now what do I have to do? The leading one has to be 1. I got to first factor out a 2. Okay, remember we're going to save this till later. We're going to keep that factor, save it till later. We're going to set this equal to 0. So x is equal to -1/2. And at the very end, we have to divide everything by 2. So we bring this down. What is -1/2 times 2? -1. The 2's come out. Okay. Add down. I know this wouldn't work out. Add down. Okay, so unfortunately this didn't work out very nicely. Let's see if I change this to a 7. Yeah, this is kind of bad. Let's hold off on this one. I don't want to make it worse than it is. I just want to make, but this will work out a lot nicer. Okay. Pull out your coefficients. 6. Good. So let's check. 3, 2, 1, 0. Good. Now, this leading coefficient has to be a 1. You have to do it this way. So I'm going to factor out the 3. Then I'm going to set this part equal to 0. And I'm going to hold this guy and star it so that I can get back to this. Because otherwise I'm going to forget about my 3. Trust me. All right. So let's divide by 2/3. These fractions will work out. So 6 times 2/3 is what? 4. Good. Add down. Good. 2/3 times -12. -8. Good. Add down. 9. 9 times 2/3. 6. Huh. So this is a 0. So what did this tell us? That's a root. Good. That's a root. Now, just watch up here a second. If I say x3 over x1 and I start this with x2, just let me put this up here for a second. And I was going to check and multiply this, because if I multiply these guys, they should come out to be that one. Just look at my front end. What is 3 times 6? 18. It doesn't come out to be 6, right? So we've got to take one extra step. And what we have to do is divide this whole row. Divide everything by 3. Whatever we factored out, we have to divide by. You can tell right by your front end that it doesn't work. Divide by 3. It's easier to divide by 3 before you put your x squareds on there. I think it is. 2, this become -4, 3. Now, you can put your pieces in. 2x squared minus 4x plus 3. Now if I check this with my 3x minus 2, watch. Here's the easiest way to check this. Front ones. 3x times 2x is what? 6x cubed. So that's what I wanted, right? Check the last one. -2 times 3 is what? -6. Chances are, if you get the front one and you get the end one correct, you probably got the middle ones correct. Because if the middle ones were not correct, you would have not gotten the last ones correct. So rather than me having to multiply it all out, gathering up all my like terms, just check the front end and the front one, the last one. And that one tells you got your synthetic division okay. Okay? Okay. All right, let's try another one. Let's do a double one. Are you guys ready for a double one? Okay, sure, this one's a tough one. This is our double one. First of all, pull me out the leading coefficients. 1. So let me check. 3, 2, 1. Whoops. 0. I need a 0 here. Now, our denominator, our leading coefficient is 1. So your leading coefficient always has to be 1. We only take the last 2. Here. Now when we do a double divide, we do this differently. We say, take this guy out the opposite way, take this one out the opposite way. And we're going to divide like this. This one's different than the last one we did, because this has 3 positions in the denominator. We only want the last 2, as long as our leading coefficient is a 1. If our leading coefficient was not a 1, we would have to factor that out first. But I'm not going to give you one that's not a 1. A double divide is enough for you to do when this is 1. So we're going to take these out and put them right here, just like we did with the other ones. Now remember, we always multiply from the left to the right. It's just this time, you have 2 things to multiply. So start by bringing down your 1. You need a starting place. From the left, and the left of these. So 3 times 1 to the right. 3. You got to do your negative 1. Negative 1 times 1, well, up to the right, which I did. So to the right of that, negative 1. Okay? Add this column down only, the one right next to this. This gives me a 1. I start again. From the left, 3 times 1 to the right. Negative 1 times 1, negative 1. Now, normally I would stop and add down, but since I'm till the end, I'm going to add all my columns down that need to be added down. So this will give me 7, and this will give me negative 1. Okay, so far? Okay, so now, front end. If I have x3 over x2, what's my answer going to start with? X to the 1, right? So, x to the 1, x to the 0. This must be my remainder, because I had 2 positions to do. So I got 2 positions for my remainder. So work it backwards. This is x0, this is x1. I'll never give you one that has 3 in the remainder. So this is going to be my 1x plus 1. And run your remainder like this. Put a plus sign, then go 7x minus 1 over your denominator. Okay? Everybody good with that? All right. I usually put these in parentheses. I always leave it a plus. Even if you have a negative sign there, just put the plus. If you had this, I would still do it that way. I would do the x plus 1 plus and do it like this over the denominator. Because what happens is with that negative sign, you only pull the negative sign out for the first one. It affects the second term. So just put a plus and then put your other 2 terms where they belong. Are we good with this? Want to try another divide? A double one? Okay, I'm going to have you guys do this. Okay. It's a little weird looking because I made it up, don't forget. So what are my coefficients?
1, 3, 0.
Good. Good. So 4, 3, 2, 1, 0. What am I going to divide by?
2, 1.
Good. Very good. Read it left to right. Everything's left to right. So left to right, multiply. 2 times 1, 2. 1 times 1, 1. Stop right there. Add it down. Multiply left to right again. 5 times 2 to the right. 10. 5 times 1, 5. Stop. Add this guy down. 2 times 11 to the right. 1 times 11 to the right. Once you reach this point, the end, add everything down. So this is going to give you 26, 15. So what is my starting exponent going to be? X squared. Good. X squared plus 5x plus 11. Oh, this must be my remainder. So x0, x1 plus, I'm just stringing this along, 26x plus 15 over my denominator. Okay? A little different. If you want me to write the whole thing out, I'll write it here. Confusing what? Yeah, the double, I gotta say the double is a little confusing. But your pattern is there. Your pattern